Hello, this is Dr. Rody, and in this video I'm going to work this problem where we're going to determine where this exponential function with base e is increasing, decreasing. So here I have an exponential function base e, the exponent here has 4x squared, and my first step here is to find the critical numbers. Now this particular function is defined for every value of x, so what I'm going to do is look at the derivative and see where that derivative might be equal to 0. Well, to take the derivative of an exponential function, I rewrite the function down, and then I take the derivative of the exponent. Well, the derivative of this exponent is going to be 8. 2 times 4, 8, x to the 1, 2 minus 1. So this is going to be multiplied by 8x, like that. Then if I clean it up, I get the derivative of this function is 16x e raised to the 4x squared. So now what I want to do is take this derivative function and set it equal to 0. Now I could use logarithms and actually solve for x here, but I really don't need to. I can take a shortcut. So let's reason this out. This is a product of 16x times e to the 4x squared. Now e to the 4x squared is always positive. E is a positive base, and I'm raising it to a power. So that's always going to be a positive number. However, here, okay, if I put in 0 for x, let's consider where this product might be 0. Well, if any number in a product is 0, the whole product is 0, right? If any of these factors, I should say, if any factor within a product is 0, then my result will be 0. So I know this is always positive. However, when would 16x be equal to 0? Well, you can figure that out just, mentally. 16x would be equal to 0 when x equals 0, right? So my critical number is x equals 0. So what I want to do now is I want to draw a line here, just a little number line, and we only have one critical value, so that's kind of nice. What I'm going to do is just pick any value to the left of 0. Well, let's pick -1, okay? And if I put -1 in here, 16 times -1 is negative. So I'm just going to kind of look at the sign. What's happening with the sign of the number, positive or negative? I don't even care about the actual value. So that's going to be negative. If I put -1 here, I get -1 squared, which is 1, and I get e to the 4. Well, e to the 4 is positive. I don't need to evaluate what exactly that number is. Negative times positive, well, that's negative. So -1 is in this interval from -infinity up to 0. And then so let's look at 1. Let's make it easy. And you can use a calculator if you want and just plug the numbers in the calculator and see if the result's positive or negative. But in this case, I can say, look, if I put 1 in here, well, I already established before that that piece is always positive, right? If I put 1 here, 16 times 1 is positive. Positive times positive is positive. So the derivative is going to be positive from 0 to positive infinity, and it's going to be negative from -infinity to 0. Well, where the function is negative, it's decreasing. Where a function is positive, it's increasing. So the result of this, where is it increasing, where is it decreasing? In interval notation, the function here is increasing on the interval from 0 to infinity, the open interval, right? We don't ever put a closed interval on infinity, and we're not at 0. The derivative is 0 there. So it's neither increasing nor decreasing. So that's our increasing interval along the domain of the function. And then what part of the function is what part of the domain, I should say, of this function is the function decreasing? Well, if I look at this chart, the derivative is negative from negative infinity to 0, and so that is the span along the domain for which this function is decreasing. So that is how you work a exponential problem here like this, in this form, to figure out where the function is increasing or decreasing.